Good morning, students. This class we will discuss about micrometer and their parts. Screw gauge or micrometer screw gauge is a measuring instrument. It's used for precise measurement. So, particularly to measuring small dimensions. When you have to measure that small dimensions, that micrometer screw gauge is preferred. Can even measure dimensions smaller than those measured by vernier caliper. So, vernier caliper can able to measure 0.02, here that micrometer 0.01 mm. So belonging to that family of calipers. This is that group of same family. So the calipers means measure the dimensions of an object. So micrometer screw gauge also consists of two different scales. In vernier, so you have main scale and vernier scale, and micrometer main scale and thimble scale reading you have to calculate when you have to take that measurement of an components or objects. So micrometers based on screw and a nut. So when you have to rotational movement, you have to move that linear movement with the support of screw and nut. As the screw rotates one revolution on the screw, then the screw moves linearly by one pitch distance. So based on the revolutions, it will be calculated. So based on screw and nut movements, which means that on completing exactly one revolution, the displacement achieved by half of one revolutions, it will be completed 0.5 mm move in that main scale reading. Minimum length can be measured the screw gauge. Screw pitch divided by number of parts circumference. Screw pitch like 0.5 mm divided by number of parts, 50 parts there divided to get that accurate value. So minimum length is 0.01 mm to measure with the support of micrometer screw gauge. Next, micrometer parts and their functions. These are that micrometer. Here that C or U-shaped frame. So the remaining parts is available here. This is anvil and spindle. These are the faces it will be used to hold that object when you have to take that measurement. So this is that index line. This is that sleeve scale, main scale. So each and so in top of the place is 0, 1, 2, and bottom side zero point 0.5. So you have to measure that zero point 0.5 mm. So here that thimble scale, so 50 divisions is there. Each and every divisions is 0.01 mm. So finally have to add that value, main scale and thimble, have to calculate that micrometer screw gauge reading. This is the ratchet. So it will be moved to left hand side of that spindle. So when you have to touch on that body to give that sound like that warning, so immediately you have to stop to rotate that ratchet. So U-shaped steel frame. U-shaped or C-shaped frame will hold all other parts together. So already I said earlier, gap between two frames in the U or C shaped frame determines the maximum diameter of that workpiece. So in that micrometer they are mentioned 0 to 25 mm, 25 to 50 mm. So that spindle it will be moved to that maximum dimensions. You have to measure with the support of the particular instruments. This frame is heavily and thick, which makes it difficult to strain under mechanical and thermal stresses. So in this reason, very heavy frames they are used. Suppose we unfortunately have to fell down, so not damage. So you have to use properly and to get that good life of that particular micrometer. Next, anvil and spindle. The part that rests on one side of the frame. So anvil is a place on the left side of the frame is a fixed. So spindle is movable to adjust with the support of ratchet to hold that objects. Anvils are the measuring faces. They are attached to spindle face and fixed face on that frame. Spindle moves towards that anvil when in order to hold that object and take that measurement. So it will be that these are the two measuring faces. The left side anvil, the right side spindle. So you have to place to hold that object between the anvil and spindle. You have to move the spindle left and right with the support of ratchet. When you have to touch on the body in that spindle faces, you have to stop, and also to give that sound and warning from that ratchet. Then you have to stop the process, and you have to lock that lock screw. Then you have to take that machine. So spindle will move, the threads act as a screw. It should be run freely and smoothly to length of its travel. So the nut and screw that arrangements, it will be help to move that spindles very freely. It will be connect. It will be hold that objects easily. Next we will discuss thimble, which is turned by thumbs, which makes that spindle movement. This is that main scale. So each and every distance 0.5, 0.51 mm. This is that thimble 0.01 mm. So which is having 50 divisions on its circumference will be moved over that barrel. So this is that arrangements of that micrometer. So ratchet. Ratchet will be provided at the end of the thimble. Ratchets it will be provided at the end of that thimble to assure accurate measurements by preventing too much pressure being applied on the mic. Already I said earlier, how to stop the process and that necessary place. Sleeve or barrel having 0.5 mm divisions length along the length of the sleeve. So this is that the 0, 0.5, 1, 1.5, 2, 2.5 mm. This is that main scale for that micrometer. So this place is in that micrometer. This is that main scale. Lock nut is the lock the spindle without altering the distance between measuring the faces. We no need to worry about it. Just you have to hold that object. You have to lock that. Then you have to take the measurements without any fear. You have to take it. Next, setting 0. So when you have to take that measurement of component or object, we have to confirm with that micrometer having that 0 error. So that time without hold that objects, I have to move the spindle towards that anvil. That time I have to check that 0 it will be coincide properly. So if it's properly coincide, there is no error occur on the particular instruments. If any error is there, we have to correct it. To take any measurements with the micrometer screw gauge, it's necessary to set 0 to avoid errors. Rotate the thimble until two measuring faces meet each other. The ratchet starts slipping. If the 0 mark on the sleeve thimble is not coinciding, so already I said earlier, with the 0 divisions on the sleeve, then it should be considered that micrometers as an error. So if any error is there, immediately have to correct it. Then you have to do that process. Next, reading that micrometer. Select the suitable micrometer size depending on the size of the workpiece. So what type of components you have to measure and availability of the micrometers based on you have to choose that ranges from 0 to 25, 25 to 50, 150 from 125. These types of dimensions available micrometers is there. Check that 0 error. Place the object in between the two measuring faces and rotate the thimble to make the spindle touches of objects. Then you have to take it. Rotate until when ratchet starts slipping. Now take the reading on the main scale and the sleeve. This is that have to take that reading from that main scale. Take the thimble reading, which by where the thimble coincides with the reference line to the sleeve or main scale. So finally, the micrometer readings calculate main scale reading plus reading of thimble into least count. Here least count 0.01 mm. So we have to calculate that micrometer. Next, advantages of micrometer. Ratchet stop mechanism ensures that uniform pressure is applied to that temple. So the type of facilities is not available in that vernier caliper and other instruments. So this is to give that warning to that experimenter. So to get that good accurate value from that compounds. Micrometers are very durable as a result. Their backed enamel frame and tungsten carbide tip. This is that backed enamel frame they are used and tungsten carbide tip to so have good wear and tear withstand material. So you have to use properly, use carefully. You have to handle. So the life of the instruments is good. Next, disadvantage. Most micrometers have a measuring range only 25 mm. Additional micrometers are required to measure that larger objects. This is that one of that drawback. In examples, you have to take that vernier caliper, so maximum 150 mm to 200 mm length you have to measure with the support of. This is that one of the drawbacks. Unlike vernier calipers, which can take the number of different measurements, of course, outside, inside, depth, have to easily to measure with the support of a single instrument. In micrometers are only capable of performing single measuring. So if you want to measure outside, you have to choose one. If you want to measure the depth of the particular compound, you have to choose that depth micrometer. These are the drawbacks of micrometer. Thank you.